Ever wished working with data could be faster? What if you could process larger data sets more efficiently? That's where Polars come in. Polars is a fast, efficient data frame library designed to make data handling and manipulation quicker. It's written in Rust, which gives it C++ level performance, allowing it to optimize the most performance critical parts of its query engine for speed. Polars is also very lightweight. It comes with zero required dependencies, and this shows in the import times. It also supports all common data formats, so whatever data you're working with, Polars can handle it. When it comes to core data structures, you've got two main players similar to Pandas, series and data frames. First up, series is a one-dimensional data structure where all elements are of same type. Think of it like a column of numbers, strings, or dates. And then you've got data frames, a two-dimensional heterogeneous structure, essentially a table where each column or series can hold different types of data. Now let's take a closer look at one of the biggest benefits of Polars, the columnar format. In row-based storage, each row is stored in a contiguous memory blocks. The data for different rows can be stored scattered in memory depending on the storage engine, but within each row, the data for all the columns are stored contiguously. Let's say you want to access a third element in second column, which would be C here. In a row-based layout, the system must first find the third row in the memory, which could be in any part of the memory, then retrieve the second value from that row. This means that you have to access the entire row to get the value. This results in unnecessary data being read into memory, which is inefficient, especially if the row is large or contains multiple columns. In some cases, rows might not be stored in the contiguous block of memory. Example in databases with indexing or in distributed systems, making the process of accessing a specific row even more inefficient. However, in columnar storage format, data for each column is stored together. This means that when the storage system loads data from a column, it can directly compute where the column begins and where it ends in memory. If you want to access C1, say the third element, which is 3, the system can directly jump to column 1. Say the memory begins at A0, it can compute the address of the third element and fetch the value. Here's the summary of comparison between row-based and column-based storage systems. Row-based storage is optimal for transactional systems where entire rows of data are frequently accessed and processed together. However, it is inefficient for analytical workloads, especially when only a subset of columns is needed. With Polars, you can use expressions, which are lazy representations of transformations you want to apply to your data. This allows you to efficiently select, filter, group, and even add new columns. Here's the quick comparison of Pandas versus Polars. Now let's solve intro to Pandas LeetCode questions using Polars and get familiar with its syntax. The schema parameter is used to define the column names when creating a data frame from a list of lists or other data sources. This is necessary when you want to assign a specific column names to the data you are importing. The shape method returns the dimensions of a data frame. It returns a tuple in the form of rows, columns, providing the number of rows and columns in the data frame. Head method returns the first few rows of a data frame. By default, it shows the first 5 rows, but you can specify a different number by passing an argument. Filter method is used to select rows from the data frame that meet certain conditions. The condition is typically expressed as a Boolean expression applied to a column. You can filter rows based on conditions, such as selecting rows where a column matches a specific value. pl.call is used to reference a column in a data frame, allowing you to perform operations on it. With columns method allows you to add or modify columns in a data frame. You can use it to perform operations like creating a new column. Here we use pl.call to select a column and with columns method to add new computed column to the data frame. The alias method is used to rename the new column. Unique method returns a data frame with duplicate rows removed based on a subset of columns. You can specify one or more columns to identify duplicates. IsNotNull method is used to filter out rows where a column contains non-null values. It checks whether the values in a given column are not null, and it returns a Boolean mask that can be used for filtering. Rename method is used to change the name of one or more columns. You provide a dictionary where the keys are old column names and the values are new column names. Cast method is used to change the data type of a column. To change the data type of a column, you use this cast method inside with columns. Fill null method is used to fill missing or null values in a column with a specified value. For example, you can replace nulls with 0, a string, or even a calculated value. VStack method allows you to concatenate two data frames vertically, that is, stacking rows from one data frame onto another. Pivot method reshapes a data frame by pivoting it around a specific column. You specify index, the column to group by, on parameter, which is the column whose unique values will become new column names, and then the values, the column whose values will populate the reshaped data frame. To convert a wide format data frame with multiple values in separate columns into a long format data frame, we can use unpivot operation. Here, unpivot method reshapes the data by turning columns like quarter 1, quarter 2, etc. into a single column, say quarter, and another column sales for corresponding sales values. The product column is used as an index or row identifier. Here's an example of method chaining. Filter method filters rows based on a condition. For example, here it keeps only the rows where weight is greater than 100. Then sorts the data frame by a specified column using sort in descending order. Finally, select specific column from data frame using select method. Here it extracts only the name column from the data frame. Thanks for watching. I hope you enjoyed the video. If you did, check out my other videos in Pandas LeetCode playlist. Don't forget to hit that like button, subscribe and ring the bell so you never miss out on future content. See you in the next one.